Consider the two algebraic fractions shown. What we want to do is to express those with a common denominator. Now I hope you can see that the lowest common denominator is going to be x plus 1 all squared. So I must multiply this by x plus 1 to get the common denominator. I therefore multiply the numerator by x plus 1 as well. And I don't have to multiply the 2 by anything. And this gives 3x plus 3 plus 2 is plus 5, and then x plus 1 all squared. Now, this is what we call a repeated linear factor. We've got x plus 1 times x plus 1. Now, when it comes to splitting it into its partial fractions, that is to say, these two terms here, we have to have a over x plus 1 as the first term, and then b over x plus 1 all squared. And we would proceed from there to find the values of a and b, but this is what we have in the first line. Now here is the repeated linear factor. So the first term we're going to have is a over x minus 2, then we'll have a b over x minus 1, and then we'll have a c over x minus 1 squared. So 3x squared minus 11x plus 5. I'm going to multiply, so I'm going to multiply x minus 2 by x minus 1 all squared to get the lowest common denominator. So I must multiply the a by x minus 1 all squared. I'm going to multiply this by x minus 2, x minus 1. And I'm going to multiply this by x minus 2. Now in this example I've cut out an intermediate line. I hope that this is okay. So what we do now is we choose values of x that make the brackets on the right hand side equal to 0. One at a time. I'm going to choose x equals 1. The left hand side gives me doesn't give me 5 at all, it gives me 3 plus 5 is 8. 8 take away 11 is minus 3. So this bracket and term and this bracket and term disappear, and we're left with 1 minus 2, so it's minus c, and c then equals 3. X equals 2, so 3 times 4 is 12. 12 plus 5 is 17. 17 take away 22 is minus 5. Now, so I hope you can see that with x equals 2, this bracket and this bracket here become 0 and the terms disappear. So we're left with the first term. 2 take away 1 is 1, 1 squared is 1, so it looks very much then as though a is minus 5. Now, how do we work out the value of the final coefficient, c? Well, what we do here is we just choose another value that's of x that's easy to work with. X equals 0 is a nice easy value. It reduces the left hand side to 5. So we've got, if I put x equals 0 in here, I have minus 1 squared, so that's a. If I put x equals 0 in here and in here, I have minus 2 times minus 1, which is 2. And and then minus 2c. I already know the values of c and a. A is minus 5 and c is 3. So I get 2b equal to 16 and b equaling 8. So it's a over x minus 2, a is minus 5 over x minus 2. B was 8 over x minus 1, and c is 3, so it's 3 over x minus 1 all squared. That's the first example then, dealing with a repeated linear factor. Here's example 3. We have to fully factorise the bottom lines. That's going to give us 7x squared plus 1. We'll take out x squared as a common factor, the highest common factor, and that gives us x minus 1. Now, here is the repeated linear factor, so we're going to have a over x plus b over x squared plus c over x minus 1. Next line, 7x squared plus 1, dealing with the numerators. Well, what do I multiply this by to get the common denominator, which is this here? I multiply by x minus 1. So I multiply the a by x minus 1. And I'll multiply b by x minus 1. And I'll multiply c by x squared. Values of x to work with, let's just choose x equals 0. Left hand side gives us 1. This term is 0, this term is 0, so we have minus b. B then has the value minus 1. X equals 1, the left hand side is 8. This term is 0, this term is 0, and we have c. Now we're going to have to choose another value that's easy to work with. I'm thinking I'm going to have, let's just have x equals 2. I think I want to have a positive value. 2 squared, so we're dealing with the left hand side now. 2 squared is 4, times 7 is 28, plus 1 is 29. Now, that's 2 lots of a. 2 take away 1 is 1, that's a b, and then 4c. So we can sub in the values that we know. 29 equals 2a plus b. 4 times c, 4 times 8 is 32. 29 plus 1 is 30. 30 take away 32 is minus 2. A then has the value minus 1. So, original problem then, 7x squared plus 1 over x cubed minus x squared. It was a, which was minus 1 over x plus minus 1 over x squared, because b has the value minus 1 as well, plus 8 over x minus 1.